playing a video on the internet seems simple. You press play, the video gets delivered, and boom, you're watching Game of Thrones, right? It's actually a bit more complicated than that. Unless you've built an application that involves video, you probably have not dealt with the world of codecs and bitrates and streaming. Depending on the bandwidth between the user and the server, you might want to use different compression rates. Think about all the different use cases. There's different connection speeds, different device types, operating systems, video players, cloud providers. As a developer, you just want videos in your application to play quickly and reliably. But it takes a lot of engineering and monitoring and re-engineering to actually get it right. McClure and Jon Dahl are the founders of Mux, a company that makes video infrastructure technologies. Previously, they built Zencoder, which is a product for encoding and delivering video, so these guys know as much about video playback as anybody. This episode was a fascinating discussion of why building video products for the modern internet is still so hard, and some techniques for overcoming those difficulties if you are building video products. If you want to hear all of our old episodes about building cloud infrastructure, you can download the Software Engineering Daily app for iOS. It will also be out for Android quite soon. It gives you the ability to hear all of our old episodes, and they're indexed by what would be a good recommendation to you based on what episodes you've listened to and what you've upvoted. It'll also give you an ability to search through all of our 600 episodes, and you can download what you want and easily find new shows. With 600 episodes, I know that it's hard to find the episodes that might appeal to you, and we hope that the app helps with that. We've got an Android app on the way. The iOS app is the first project to go live out of the Software Engineering Daily open source project. This is available at github.com/softwareengineeringdaily. And there are more projects on the way. We're looking for contributors. So if you want to help build a better Software Engineering Daily experience, you can check out github.com/softwareengineeringdaily. We've got an Android app. We've got the iOS app. We've got a recommendation system and a web front end, and all of these projects, they are getting some contributors, and we'd love to have you as a contributor as well. And if you have any recommendations for what you would like to see in the app, you can always join the Slack channel or send me an email, jeff@softwareengineeringdaily.com. Heptio was founded by two creators of the Kubernetes project to support and advance the open Kubernetes ecosystem. Heptio unleashes the technology-driven enterprise with products that help customers realize the full potential of Kubernetes and transform IT into a business accelerator. Heptio's products improve the overall experience and reduce the cost and complexity of running Kubernetes and related technologies in production environments. They build products, they build open source tools, and they provide training and services and support that bring people closer to upstream Kubernetes. You can find out how Heptio can make Kubernetes easier at softwareengineeringdaily.com/Heptio. Joe Beda and Craig McCluskey, who are the founders of Heptio, have both been on Software Engineering Daily, and they were fantastic when they came on. They were really fluent in what is going on in the Kubernetes ecosystem because they helped build it. So to find out more about the company that they're building with Heptio and to find training and resources and products built for Kubernetes, go to softwareengineeringdaily.com/Heptio. And thanks to Heptio for being a sponsor of Software Engineering Daily. I'm really proud to have the company on board. McClure and Jon Dahl are the founders of Mux. Guys, welcome to Software Engineering Daily.
Thanks. Thanks. Great to be here.
You are both experts in video engineering, and I want to dive deep into video engineering. Let's start at the high level, though. When I play a video from my browser, what happens?
A lot. It's kind of a miracle that it plays. Maybe, Matt, you want to start at the browser side and then kind of go from there?
So you're a user of some video platform. You go in and find the player find the video you want to see. So you go in and click play. If we're on a platform that's been adopting modern codecs and streaming standards, then they're probably using something called HLS or Dash, which are both adaptive bitrate streams. So when you click play, the video player, and this is all typically done in JavaScript now rather than just letting the video element do it, but the video player will use the default bitrate that's currently that's this first in the manifest, and then based on how much bandwidth you have available, it'll switch to one of the other renditions in this playlist. So we can go more into the details there later, but yeah, essentially you click play, it starts playing whatever it has first, and then it'll try to find another version of that asset that's better for whatever your bandwidth is. So if you're on a high bit rate, 100 megabit per second connection, you'll get the 1080p version. If you're on a 56K modem, you might get audio only. So yeah, then your player keeps requesting new files from the server and just playing them back as it gets them.
The server is hosting a variety of different quality levels of a video that I'm requesting. Is that what you're saying?
Yep. Mm-hmm.
Okay. So is this the same strategy that all different video delivery services are going to use? Like, is YouTube using this? Does Netflix do something similar? What about video advertising? Are these all doing a similar thing where they're giving me a video based on my connection?
Yes, pretty much everyone does this. Maybe the places you wouldn't see this would be in like a point-to-point communication. You probably just have one video stream going back and forth in like a real-time chat. But just about everything else uses this model. And
so other than connectivity level, is there anything that differs between a mobile playback and a desktop playback? Like if I'm sitting on my laptop on Wi-Fi and sitting on my mobile phone on Wi-Fi, how is my video playback experience going to differentiate?
Yeah, so lots of ways. You can start at the device itself. The resolution is probably different. If you're looking on a nice new iPhone, you have a nice display. If you're looking on a worse mobile device, you don't have a great display. Same is true of laptops or desktops.
Yeah, on the player side of things, this is where it also gets pretty interesting regarding support and what the player itself has to do. So, for example, with projects like Contrib HLS, they need to do all this additional work to play back HLS in browsers that don't natively support it. So Safari, iOS Safari, most modern Android devices all support HLS and the underlying codec container, TS, but a lot of browsers don't. So what Contrib HLS has to do is actually, and other HLS player plugins, if you want to call them that, do it as well. But they'll actually need to transmux the TS segments. So it'll need to convert these TS segments that it gets back. So these are typically 10-second chunks of video, convert them to a format that browser can support in JavaScript before feeding it into the browser's playback mechanism.
Would it be helpful to do like quick definitions on some of these things?
Yeah, sure. I was thinking about going through that. Anyway, yeah, sure. So why don't you give us an overview? What are the definitions? What are the vocabulary that we need to know to start to understand how video engineering works?
Yeah, so starting at the top level, HLS and Dash are the two main formats that people use for adaptive streaming. And actually what they are, HLS stands for HTTP live streaming, Dash is like dynamic adaptive streaming over HTTP. What they really are is like kind of brilliantly stupid ways of delivering video over the internet. They're text files. So HLS is like a text file that uses the old like Winamp playlist format. And Dash is like XML. And all it is a list of little files. And they point to all these little files that are sitting out on servers somewhere. And so the player grabs the text file, the manifest, and is like, all right, I want to play the first 2 seconds of this video. And it points, and it knows the URL of the first 2 seconds of the video, and it plays that. And then it plays the next 2 seconds and the next 2 seconds. And what this does is let you switch back and forth between higher and lower bitrate renditions as your bandwidth changes. So if you go through a tunnel, maybe you go through a worse rendition, or if you are on a great connection at home, you maybe have good consistent bandwidth.
So another vocabulary word that I think we should get out of the way is codec. What is a codec?
The codec itself is how the video file itself is encoded. So that's the compression algorithms, things like that. A lot of people confuse, like when you say MP4, this is an MP4 file. A lot of people assume that's the codec, but all that actually is the container. So a container is just a definition for how a file can have audio and video tracks, but it doesn't necessarily specify what the underlying format of those audio and video tracks are. So what we see probably the most common one that you'll see online right now in the wild is H.264 is the codec, and then the audio codec could be something like OGG or Speaks, I don't know what else. But for example, YouTube pushes a lot of VP9 as their codec, and that's usually in the WebM container. So yeah, those are two phrases that are like typically confused, but fairly different.
Mm-hmm. So when I take a video and I run it through a codec, it's essentially it's compressing it, right? It's encoding it in a compressed format so that it can deliver more efficiently. Is that accurate?
Yeah, and the reason is video is just ridiculously big if you don't compress it. So like a standard DVD would hold maybe like 20 seconds of video if you didn't compress it. You usually get like about a 97% compression ratio from raw video to what you actually watch when you watch video online. So video is already like the most of the traffic on the internet. Now imagine multiplying the size of video by 30x and like the internet would break.
Wow. Okay. So when I run my video through a codec, does it get or if I'm uploading it to a service, you mentioned that there's a server somewhere that holds a bunch of different video quality videos that are going to be delivered to me based on what my connectivity speed is or whether I'm on mobile or on desktop. So does a single codec handle the ingestion and spitting out of the video into all the different formats, or do I need different codecs for all of the different quality representations I'm going to make?
It can be one codec, and for the last 5 to 8 years, one codec has been pretty dominant. That's H.264. So you can use that for that input file. Like your camera can produce H.264, your editing software can produce it. You can upload that to a video publishing site. They can deliver H.264 to almost every device. There are next generation codecs like HEVC and VP9 and AV1 that are coming that are better than H.264 and will. Yeah, go ahead.
Well, so I was going to say, I listened to your podcast, the Demuxed podcast, and you were talking about some different codecs. Like I think you were talking about how Apple and Google codecs differ, for example. What are some of the different trade-offs you can make in a codec design?
So the biggest one, and this is the biggest difference so Apple generally falls on the H.264 side of things. Google typically falls on the VP9 side of things. So the trade-off between those two codecs is compression efficiency versus compression, like how hard it is to compress it. So H.264 it's typically a lot easier compute-wise to encode a video into H.264, but your file sizes are typically bigger. So if you have YouTube, for example, where you don't really care about how much compute it takes for you to get your files out because you have basically limitless supplies, then it makes more sense for you to spend the time up front, get those files smaller so that you can save on the epic amounts of delivery that you have to do. If you're paying more for compute than delivery, then it probably makes sense for you to go with something like H.264.
And there's one other trade-off, and that's kind of the patent landscape. So H.264, H.265, which is also called HEVC, and honestly, most video technology is heavily patented. And so you get these patent pools that are ways of licensing the technology. Like in order to watch a video, you are referencing 250 patents owned by Microsoft and Nokia and companies that don't exist anymore and all sorts of places. So you can license those, and sometimes it's not that expensive, sometimes it is expensive, but you're kind of beholden to the patent holders. VP9, the Google tech tree, is totally patent free, and they actually acquired a company a while ago that was really the only, or one of the only, like independently developed codec technology trees that was developed outside of the patent landscape. And Google bought them just for this tech tree, and then they've been investing in it. So there's now like a royalty-free, patent-free codec.
Why is that? Why is there such a fraught patent landscape in the codec world?
I think partly just because of how complex this compression is. Like you can't just invent like a way of moving pictures to 97% compression. You have to apply dozens and dozens of different techniques. When you look at how video is compressed, it's not any one thing. There's just trick upon trick that's like put into video compression in order to get file sizes down.
There's a term I want to enumerate for people who may not know the definition. Can you define the term bit rate?
Yeah, sure. It's basically what's the number of bits. So a bit rate is usually expressed in megabits per second or kilobits per second. So it's the number of bits of data per second. So for download, like if you're downloading a file, it's how many bits am I downloading every second. If you're talking about a video codec, like a video might have a bit rate of 2 megabits per second, or your AAC audio you download from iTunes might have a bit rate of 128 kilobits per second. Then it's talking about the number of bits per second of playback. So if you listen to 1 second of video or of audio or watch 1 second of video, how many bits are used to store that second?
How does video quality relate to that bit rate?
So that's actually, it's interesting because a lot of people assume, naively, when I'm coming from just watching video online and I hear something like 1080p, then you assume that comes with some kind of quality assurances, but actually doesn't. So it's the combination of your resolution, so like in terms of how big you can actually make this file before you start scaling it when you're playing it back, versus the bitrate. So the combination of those two things, where if you have, a 500 kilobyte 1080p file, that's going to look awful at 1080p because it has to do so much compression to be able to get that much information into that bitrate. But a 2 megabit 1080p could look great, right? So it's, typically when you're watching it, bitrate has the combination of bitrate plus resolution is your biggest indicator of how good that file is going to look.
Yeah, it's not perfectly linear. You could have two videos where the lower bit rate actually looks better than the higher bit rate, but it definitely is correlated. To use a stupid analogy, it's like maybe horsepowers on a car or something like that. Like all things being equal, higher horsepower is probably going to be a faster car than a lower horsepower, but that's not always true.
Grammatech Code Sonar helps development teams improve code quality with static analysis. It helps flag issues early in the development process, allowing developers to release better code faster. Code Sonar can easily be integrated into any development process. Code Sonar performs advanced static analysis of C, C++, Java, and even raw binary code. Code Sonar performs unique data flow and symbolic execution analysis to aggressively scan for problems in your code. Just like battleships use sonar to detect objects deep underwater, engineers use Code Sonar to detect subtle problems deep within their code. Go to go.grammatech.com/sedaily to get your free 30-day trial exclusively for Software Engineering Daily listeners. Code Sonar analyzes your code, and it delivers a detailed report. The Code Sonar user interface provides all the information that you need to quickly understand the reports, follow cross-functional paths, understand cross-references, quickly navigate between files, and visualize large pieces of your code. Go to go.grammatech.com/sedaily to get your 30-day free trial and unleash the power of advanced static analysis. Thanks to Grammatech for being a sponsor of Software Engineering Daily. When I take a video in, let's say, Instagram, and I upload it to the server, what exactly is going on there? Like, is it getting transcoded, or I'm not sure if that's the right word. Is it getting run through a codec on my phone and then uploaded, or does it get uploaded in its purest form and then it gets transformed on the server into different compressed types?
Yes.
What's the okay?
Both of those. So your phone is encoding. So more terminology. Encoding is taking raw video and compressing it. So taking it from just being a raw, like the actual like light that hits your camera sensor, to a compressed video file. That's encoding. That encoded video, which is H.264 at whatever 10 megabits per second, is uploaded to Instagram. Then Instagram likely transcodes it again. And part of that's for normalization purposes. They don't know what's necessarily coming off your phone, or maybe you upload from a different source. It might be the wrong size or the wrong quality or the wrong codec. So they want to transcode it to something consistent across all Instagram files. They probably want to transcode it multiple times so that you have the high bit rate, the medium bit rate, low bit rate, et cetera.
And just to clarify, as John said, encoding from raw video to H.264 or something like that. Transcoding is going from that encoded format to other encoded formats. So that could be different file sizes, something like that.
Yeah, so transcoding is decoding something that's already compressed and then encoding it again. That's transcoding.
Got it. So like, I imagine there's so many different knobs you can turn, because let's say I'm going to upload my video to Instagram, and if Instagram wants to take a low bitrate version of it and then really aggressively distribute it, then it wants to just transform it on my phone, because the bottleneck is the network. So the network uploads, so it's gonna transform it into the lowest bit rate possible, upload it, and then aggressively distribute it. And then asynchronously from that, it could take the fat version, the totally uncompressed version. It could upload it to Instagram servers, and then it could encode it and then transcode it to all kinds of different versions, and then do more of a lazy distribution, more based on the performance of the recipients of that video. So I guess you're just going to be tuning the aggression with which you're distributing things versus how efficiently you want to distribute it.
Yeah, that all sounds right. The only thing you said that probably is wrong is they would never send the uncompressed video from the phone to Instagram, because it would eat up your whole data plan in like one clip.
And it wouldn't be, and it's lossless, right? If you compress it on the client and then decompress it on the server, that's a lossless process, right?
The decompression, the decoding is lossless. The encoding is lossy, so your compressed video is never going to be a perfect representation. But it can be like transparent in the sense that you would never be able to tell a difference. You could look at them side by side and have no way of telling. But technically, it is lossy because you can't get out the exact data when you decode it that was originally there.
Now, in a video compression infrastructure, it seems like we're keeping these videos constantly in a format where they can be played by a player. Like, they're never going into a zip format, right? They're just going into video formats of different levels of compression. Is that accurate?
Yeah, that's accurate. Yep. And you wouldn't get any more efficiency out of zipping up a video file. And actually, the last step, or one of the last steps in the encoding process, is something that is really just like, let's compress the bits here, just like a zip would. Where most of video compression is aware of like the images, and it's trying to like losslessly preserve the images, or sorry, not losslessly. It's trying to preserve the images as faithfully as possible with as few bits as possible. But then at the end, you do something in the codec that kind of looks like a zip.
Why is that at the end of the process? Because
just like sequentially, like if you were to zip something up and then try to do some sort of like, motion-based optimization, that wouldn't work because you've lost the image when you like do that zip.
Oh, of course. Okay, that makes sense. So let's get a little bit higher level. If we're talking about YouTube or Netflix, these companies have enormous video infrastructure. I know you guys worked at Brightroll after your company Zencoder was acquired. Brightroll works on video ad delivery, I think mostly, or I guess all kinds of video media delivery. So
yeah, it was actually Bright Cove, not Brightroll, which is
Bright Cove, right?
Right. Yes. Yep.
My mistake.
Not the first time I've heard that, to be totally clear. So
Right. Okay. So Brightcove, that's just that's just a video infrastructure company, right? Like not really related to ad tech.
Yeah, ad tech is like a neighboring technology, and Brightcove integrates with ad tech, but it is not an ad tech provider.
So were the problems that you were solving similar to the video problems that a YouTube or a Netflix would have?
Yeah, I mean, a lot of those problems are just kind of the same problems that anybody that's going to deliver video online has to deal with, right? Like huge files and all the problems that come with it, right?
And tell me about some of those problems. The larger scale infrastructure. I mean, we've been talking about what goes on when you're uploading or downloading a single video. What about when we're managing a huge pipeline and queuing and caching? What are the big infrastructure problems?
Yeah, they're all over the place. So an obvious one we haven't talked about is delivery. So you have petabytes and petabytes of video that you want to send around the world. You can't efficiently do that from a single point. So let's say Brightcove has a bunch of servers in Boston. If 1,000 people watch a Brightcove video in Australia, you don't want to send that video 1,000 times from Boston to Australia. That's expensive, it's inefficient, it's slow, it's clogging up the internet more than it already is with video. So what you do is use a content delivery network, a CDN, that basically caches a version of the file close to the end user. So the first person in Australia who wants to watch the video pulls it all the way from Boston. The second person pulls it from a server in Australia, and so does the third and the 1,000th person.
Did you have to build your own CDN for that purpose, or are there off-the-shelf CDNs like Akamai that you can use?
Yeah, you can use off-the-shelf ones. Akamai is the old one. Fastly and CloudFront are what a lot of people are moving to nowadays. You can build your own, and there's companies out there. Twitch kind of famously did that. So Justin TV, back when they were Justin TV, I don't know the whole story. I know they use CDNs in some ways, but they sent most of their traffic through their own peering relationships in their own network, and that carried over to Twitch as well.
Wow. Yeah, I'm sure they had to make some serious technology breakthroughs to make that company work. So what can go wrong when a video is played? So if I'm a user and I'm trying to play back a video, what are the types of problems that can hinder the playback of that video that can cause loading wheels of death or horrible quality degradation?
You name it. Hey, working on the Video.js open source project, the issue tracker is littered with those problems. But I mean, honestly, the most common problems are still browser support issues. So codec support is kind of one of the holdouts of kind of the browser wars, and most of the time you don't see that because at this point everybody supports H.264, for example, in some way, but that wasn't the case until really recently. So for example, if you wanted to deliver, I would say in 2012, 2011, if you wanted to deliver video reliably to every browser on the market, you were creating H.264 outputs, VP8 outputs, and OGG outputs. And then on top of that, for browsers older than maybe kind of the Edge, you were including a flash fallback to be able to support that H.264 version if there was nothing else the browser could play. So codec support in the browser itself was, until very recently, a big problem, and now it's kind of seeping back with modern codecs and these streaming codecs. So then from there, it's a lot of this is particularly with kind of these more complicated streaming formats where we're starting to see browser support issues around the fact that we're having to transmux, which is taking a video file and then making it something else in terms of without actually changing the underlying codec. So there's bits around the video file that aren't necessarily the codec itself that can change between, for example, like a TS file and a fragmented MP4. The actual complex differences between the two are relatively innocuous, but you have to have it from one to the other to be able to play back, to be able to pass it directly to a browser. So the complexities around doing that in JavaScript are taxing for large files. And so we see browsers crash all the time just from trying to do that.
Yeah, maybe other things that go wrong, and they're innumerable. The delivery layer, the CDN layer, can be fragile. Just anecdotally, I know of companies who have crashed entire countries of like major CDNs by changing the way they tune their video publishing. So they get this like huge cascade of like new requests when they weren't expected, and like the CDN is not architected for it, and cause major outages. When you're dealing with live video, which is even more complex than files, like you have an encoder on site at your live event, so you have a box, or you have a camera, or you have your MacBook, or whatever it is that's like actually capturing the video. Like those things do all sorts of terrible things when they send video up to a provider. Like you'll have like one encoder that'll crash every 4 hours just because of the way they implemented timestamps on their feed. All sorts of things like that.
You mentioned Video.js. What is Video.js? I know it's a project that you're both working on. Describe what it does.
Video.js is, if I recall correctly, I think it's kind of the first HTML5 first player on the internet. So I was talking earlier about needing that Flash fallback in 2012. Before that, and even at the time, honestly, Flash first was totally a thing. So you had a Flash player, and you would play back like FLVs, which are basically like a Flash codec. So to play back a video, you would have to have Flash or just download the file. I remember like eBaum's World back in the day. This is like one of my favorite examples. Like eBaum's World back in the day, if you go back on Wayback Machine, actually just has right-click download as like how to watch videos on their site at one point. So we went from there to giving Flash players to everybody and just playing back in that. And things kind of like browsers started releasing experimental support for the video tag. So if you have a video file that the browser supports, you just put it in this video tag just like an image tag, and it just plays back. So Video.js was kind of the first open source project to start there. So the first thing it would try to do would be to play back the file in the browser itself. If the browser supported it, it would just work, and it would give you a nice way of like modifying the controls, for example, and styling them so it wasn't the default of the browser. And then if your browser didn't support that file, then it would try to play it back in its Flash fallback. But that was kind of the last resort. So that was Video.js's kind of huge, like that was what made Video.js a big deal when it first came out. These days, that Flash fallback, it's actually removed from core, which is a huge deal, especially with things like Chrome disabling Flash by default.
I don't know if you've heard this, but Flash is generally considered a bad thing nowadays.
I have heard that.
So yeah, with that, we've actually pulled Flash out of core, so you can still use it if you need to, but it's you can have to kind of pull it in via a different plugin. But now, luckily, a lot of the heavy lifting for kind of the edge of complexity in video can be done in JavaScript. So that's where plugins, and so I think Video.js has a huge place in the world today as kind of allowing you to build reliable plugins on a common abstraction layer. So you can style your player the same way across different browsers and devices. You can support HLS and Dash across these different devices via just pulling in plugins from the community.
So help me understand, what is the motivation for you to work on Video.js? Because what we should give people more color on is you guys are working on Mux, and Mux is a company that you do monitoring of streaming video performance. I'd just love to know the connection between the open source Video.js project and your commercial company, which is Mux.
Yep. So we actually started the Video.js project back in the Zencoder days. So the founders of Mux also started a company called Zencoder in 2010. It was one of the first platforms for doing video encoding in the cloud. So it's like a simple API to video compression. We built Video.js then almost as a side project, and it was because we saw this huge shift coming as everyone moved from using Flash to play video online to using HTML5 to play video online. So we built Video.js, supported it as an open source project, never charged for it. It was just like a really great kind of second thing to offer our customers, help us build community and build relationships with the market. Then we sold that company, including Video.js, to Brightcove. So Brightcove now is the maintainer of Video.js. They use it. It's the core of their video players, and they also maintain it as an open source project. But then, Matt and Steve and others at Mux continue to contribute to Video.js as an open source project, just like anyone can contribute to Video.js.
Okay, well, let's talk a little bit more about Mux. So this, again, gives monitoring for streaming video performance. Now, what is difficult about that problem? Why is it hard to monitor video streaming performance?
Yep. I'd say that the biggest reason it's hard is that a video player doesn't really know what's happening as it plays video. So we monitor things like, how does a video perform? So, for example, how long does a video take to start when you push play? How often does the video rebuffer and stall? Why does a video fail? What is the quality of the video? And if you actually look at a video player, there's no event in the video player that says, now I'm rebuffering, now I'm not, now I'm playing. You have this like underlying sequence of events that you have to interpret, and different players do it differently. Ads throw a big wrench into the whole thing. So the first hard problem you have to solve is translating this low level sequence of JavaScript events or browser events into actual metrics that are useful to you as a publisher. So that's the first thing we do. Then it's really collecting them. So we're collecting billions of beacons, billions of data, like API calls from video players. For our customers, we're aggregating them, so it's a large sort of analytics problem, and then presenting the right metrics. So we give good insights to our customers, and not just millions or billions of data points, but we actually tell them, here's how actual users experience the quality of your video. Here's where it's good. Here's where it can get better.
So if I identify some kind of problem with my video performance, what's my recourse?
Yeah, a number of things. So you got to figure out where the problem is. It could be, let's say it's a delivery problem. It could be that your CDN has an outage. So you might need to know that in roughly real time, and you could route around it. So you could send traffic over another CDN or another kind of route to get to your customers. You can call the CDN and complain, tell them to reboot the server in Sydney. A big one that's actually probably one of the most important things that video publishers do is make better decisions about your technology. So if you're gonna sign up for a CDN, you really should know how it performs, and you probably should compare a few side by side. And the same is true of video players. Same is true of your encoding settings.
Yeah, and on the player side of things, for example, to John's point of you've found some issue with delivery, right? Like you've seen that your rebuffering rate is spiking really high. That could be a problem with your CDNs or somewhere in your delivery stack, but it could also be a problem with your player's adaptive bitrate logic. So when it decides that a viewer should upgrade or downgrade which stream they're getting. So you might be mistakenly sending too much video to people that can't support it, so then they end up buffering a lot because the files are just too big for their connectivity to handle. So sometimes something like an improved algorithm on how it selects which bitrate to pick can also help with things like rebuffering.
Square is a complete omni-channel payments ecosystem where developers can create a powerful commerce solution. You've seen Square around at your favorite coffee shops and retailers, and it's trusted by millions of businesses for its simplicity and reliability. But as a developer, you can unlock the potential of a full payments and business management platform with Square's APIs at softwareengineeringdaily.com/square. There are APIs for online payments, taking in-person payments with Square hardware through a custom app that you build, and even inventory and employee management and sales reporting. Businesses of all sizes use Square's APIs to take payments securely online, in-store, and on the go with a single solution, and integrate with back-end systems that they already use. Check out Square's developer portal for all the tools that you need to get started today. Take Square's commerce solutions beyond the coffee shop and power payments for any type of business by going to softwareengineeringdaily.com/square. It's a really flexible platform for building a business with payments and everything else that you need to get started with a business. And you can check it out at softwareengineeringdaily.com/square. That's softwareengineeringdaily.com/Square, and it would support Software Engineering Daily. So thank you, Square, to being a new sponsor of Software Engineering Daily. So when you're talking about monitoring video streaming performance, what does that even mean? Because if I have like 500 customers who are all streaming my video at the same time, does that mean you're sampling the performance of all of them, or you're cloning the video stream and streaming it to your own sample? Explain how the sampling works for your monitoring infrastructure.
Yeah, so we track, for most of our customers, we track every play of a video at any time around the world.
Wow.
And everything is built up on top of that. So you can actually use our platform to dig into performance issues on like a session-by-session basis. But then on top of that, just because looking through a list of sessions is not always the best way to get data. On top of that, we also do roll those up into like hourly data points or daily data points. So we can tell you in this country, on this browser, at this time, using this, maybe this, like you're doing an A/B test using A or B, what is the startup time and what is the rebuffering rate and what is the video quality and how frequently did the stream error and things like that.
Does that mean that you have an agent on the client as well? Like if I play a video, that you need an agent on the server and the client in order to monitor that performance?
Yeah, it's not really an agent. All it is the player. The player is just making API calls about what's happening in the player. And so, we have a little bit of JavaScript you can use for that. Players can implement it themselves, but they just have to make API calls every so often with performance data for the video player.
Do you have an example, like customer, or maybe you can just fabricate one for me where you can walk me through the example where the server is streaming some video to the client and where you can describe how the monitoring infrastructure, the request and response model works there?
Sure. Let's take Funny or Die. So someone goes to funnyorDie.com, they watch the Between Two Ferns video, they hit play on the video player. At this point, Mux is not really in the picture, but as soon as they hit play, the video player starts tracking sort of the low-level events that are happening when they watch. So they know how long was the time from when you hit play till you saw the start of an ad or the end of an ad or the start of the actual content. Are you seeing the right resolution for your display? If you're watching on a TV at home, are you getting a nice 1080p picture, or are you getting like a smaller rendition, things like that? And then the player just makes API calls up to the cloud with that data. And then Mux on the back end is processing it and aggregating it for Funny or Die so that their engineers and their operations can understand what's happening.
So what is difficult about building that infrastructure? Maybe the server side, what kinds of engineering have you had to do to support the ability to monitor every video stream across all these different platforms that are your customers?
So a lot of that is scaling a large analytics platform, and this probably for people who have built analytics systems before. I think there's probably a lot of patterns that are similar once you get to the back end. But yeah, we have to collect these API calls from around the world at a pretty high rate. We use like a Kinesis as sort of a buffering layer in there, and then we process them into views that are meaningful. So we piece all these events together into like a coherent viewing session, things like that, and then aggregating that in analytics systems where you're aggregating kind of dimensionally, like we are. You have a huge, you have a very large sort of exponential storage problem. So the deeper you can dig into the data, you get to higher and higher cardinality, and you're dealing with pretty quickly with very large amounts of data storage.
Yeah, there's also, we do real-time alerting. So a nice thing about using Kinesis through this flow is that we can also have tools like Flink pulling data off of the things that are in flight to kind of try to find when error rates have spiked outside of the normal bands or things like that. And then, you were talking about more on the server side, but a big piece of this is also good clients for all of the different players that are out there. Be that web or actually things where we need a native SDK such as iOS and Android things like Roku. So.
Yeah. So you mentioned two really interesting facets of your infrastructure there, Flink and Kinesis. These are two projects that I know there are a lot of people using them, and I happen to have not had many conversations with people about them on the podcast, though. So Kinesis is a hosted eventing system, like a distributed queuing system. Actually, I guess full disclosure, they're a sponsor of the podcast, so I should mention that. This was not planned, though. Flink is a stream processing system, and I remember I did a bunch of shows about distributed stream processing a while ago, and I was doing shows about Spark and Storm and Flink. And Flink was different, and I didn't find many people who are using it. I'd love to know about those two architectural choices, because a lot of the people that are using distributed queuing systems, they might be using Kafka. There's also Google Cloud PubSub. And then in terms of the Flink stuff, I would just love to know what differentiates Flink and why that was your choice.
So honestly, the two of us probably aren't the best people to answer that question. But luckily, the guy that did, Scott Kidder, has spoken at a Flink conference recently. That talk's available online, and he wrote a blog post on it on our website, mux.com/blog. But yeah, I almost don't want to answer it because I'm at risk of just sounding like an idiot. But I think the biggest pieces, as far as I recall, in lunch conversations with Scott over why he made this call, a lot of this was around how Flink handles checkpointing and it being relatively stateless and not being able to heal. So if the entire Flink cluster goes down, that's kind of fine. It can, you will lose data for a little while it's down, but once it comes back online, it can pick back up where it left off as best it can. And how it does windowing, if I recall correctly, was also a huge feature for us when it came to doing this anomaly detection.
Right. So if you were writing like a series of, I think, Spark jobs, you would have to do some checkpointing to disk on a regular basis, or on a scheduled basis. You would have to say, okay, at this point, I want to checkpoint to disk, and then I'm going to do another MapReduce, and then I'm going to do some machine learning, then I'm going to checkpoint to disk again. It sounds like, and again, I guess we're speculating, but Flink does a little more aggressive checkpointing, or I don't know, something like that. I guess I'll refer to his blog post. Maybe I can have him on the show.
Yeah, you'd love to. His talk is actually great too on that, mostly on this topic, like how we're using it for anomaly detection, and why. So
right. Do you guys have insights on Kinesis, or should I ask him about that too?
Well, Kinesis would be other people in the company, but I mean that's Kafka and Kinesis were kind of a toss-up. We went with Kinesis because we needed to be up and running quickly.
Yeah,
and running your own Kafka cluster is a thing. So
you guys have good economics. Your business has good economics. I think if you're like, that's how I think about these host managed solutions. Like, if the economics of your business are somewhat of a commodity, then you want to go with the open source solution and manage it your own and get the costs down, and fight for the commodity pricing. But if you've got a differentiated high level product, then just go with the hosted solution.
Yeah, yeah. And so for like technically, one of the things that makes it really fantastic for us is something John mentioned, which is the buffering. So we have these microservices of collectors and processors that kind of take these beacons as they come in and do some work on them, combine them together, and then pass them off to another process. And all those connection points are done via Kinesis. If something goes down, if a piece of that infrastructure goes down for an extended period of time, we can still go back and get all the buffered data from Kinesis that we might have missed, and then reprocess it again, or for the first time if we've just been straight dropping things. So that kind of buffering that Kinesis gives us for free, or not for free, but that kind of buffering that Kinesis gives us is really invaluable for reliability in terms of our data over long times. So
you guys host a podcast called the Demuxed podcast. Tell me about the topics that you're trying to explore in Demuxed.
So Demuxed came out of a meetup that I run. It's the last Thursday. It started off as just like the last Thursday of every month, called SF Video Technology. We would get in, engineers working with video on a daily basis and have them just talk about the trials and tribulations of doing that. And then that grew to the point that eventually people kind of started asking for, what if we did a whole day of just these talks? And so then we organized the Demuxed conference, which started 3 years ago. And then out of that, we started doing a podcast, which is
October 5th.
Yeah, October 5th at North Beach here in San Francisco, Demuxed.com. Go buy tickets. But yeah, we started just having people on the show to talk about working with video every day and kind of what that means. So that's things like we talked about Video.js's recent 6.0 release and what the big changes there were there. So a lot of that had to do with like the plugin architecture and how they handle middlewares for like injecting yourself into playback, which was awesome. Accessibility problems that come with video. We're recording a show really soon with Ann Aaron from Netflix talking about the work they're doing with VMAF. So it's kind of one of those things where we expect at least like a certain amount of knowledge in the space from most of our listeners. So I imagine that if you're not at all familiar with the video space, it could probably be pretty jargony, which is unfortunate. But it's a pretty technical content for engineers that work with video. It can be fairly scant. I feel like a lot of the content that's out there right now is more for the engagement side of things, which is great. But we try to focus on the engineers building the players and the transcoding pipelines and things like that.
So take me into it. What are the biggest areas of debate and controversy in video engineering?
I mean, a huge one still, honestly, is the codec debate. For example, Google's kind of planted the flag around VP9. They try to deliver that whenever they can. And AV1 is kind of is the next generation, and it's become this consortium of companies that are involved with that. So it's Oracle, or not Oracle, Cisco and Google and Microsoft and who else is in AV1? Mozilla. Yeah, so tons of companies working together on this AV1 codec rather than just being one company's project. But meanwhile, there's HEVC, which is kind of the traditional MPEG patent pool. So it's theoretically the same patent pool rules apply. So it's do you use the patent encumbered codec or do you use kind of the open source patent royalty free codec? What else is there? There's HLS versus Dash is one that kind of rages on.
DRM is always a hot topic.
Oh, and EME. Oh, yeah. Boy.
Both in terms of how DRM is implemented and also just sort of the idea of DRM rubs some people the wrong way.
And EME, if you're not familiar, is encrypted media extensions. And the idea there was that okay, with DRM, we're having to pass around these black boxes to everybody to download, and they all kind of suck to interact with. There's no common API for these things when you're building a player. So EME was like an effort to standardize that relationship in the browser itself, and it's been a huge rat's nest. The W3C officially added it, and some people are pretty anti, but most of the people that have to work with DRM on a daily basis are pretty thankful. So,
well, as we close off, let's talk about the future a little bit. We've got VR maybe a little further down the line than people hoped for or expected, but that's certainly going to change video infrastructure eventually. Augmented reality seems to be a little bit closer. Does anything change in video infrastructure when we're talking about augmented reality?
Not really. I mean, honestly, I think for the purpose of just straight video, it's harder for me to see where we specifically, like Mux, for example, fits into AR necessarily, but VR is already. It also depends on where you draw the line between VR and just 360, for example. But it's kind of an addition on a multiplicative problem of big files. So now we go from having large files to even larger files with 360 video, and then when you start talking about actual VR, you have to start dealing with problems like light fields and how you so potentially just encoding the users or the end viewers current view frame, and then maybe a little bit of the edges, and as they move their head, encoding where their view view frame is going. So things like that are really interesting problems, but they're really complex. So, and I don't think they're terribly far away, to be quite honest.
So last question, people today can build, so I think building a simple CRUD app was hard 15 years ago. And then Ruby on Rails came out, Node.js came out. It became really easy to build a CRUD app. Mobile apps have gotten easier to build. It feels like, and I'm partially speaking from personal experience because I'm working on a video app right now, it's still kind of hard to get really good video performance. Like if I want to build a video sharing app, it's still kind of tricky. Why don't we have like the off-the-shelf tools needed to build really good video infrastructure today? And is that going to come eventually, or maybe am I not looking in the right place for it?
I think you're right in your analysis. I think it's still too hard to build, still too hard to do anything with video today. And a lot of that's just the complexity of all these different problems. I think we have a conviction at Muxa that a lot of people are on the technology side, on the vendor side, are approaching the problem in the wrong way. Maybe copying what's been done in the past and just trying to do it better, or do it in the cloud, or do it however.
Or fit into existing people's complex workflows.
Yeah.
So, yeah, people already have these complicated ways of processing video online. So if you're a vendor, you see an opportunity to make inroads just in replacing a piece of that infrastructure rather than fixing the whole thing for somebody that doesn't have any of that built yet.
Yeah. But I think what holds back the people who are working on it today oftentimes is they try to do everything, and this is just such a hard, big landscape. And every video publisher wants a different workflow, and they want different features, and they focus on different devices, and they want to make decisions about all sorts of things. And it's just hard. So YouTube can do it because YouTube is building for one use case, just YouTube, and Netflix is building for one use case, Netflix. But if you're trying to build a service for people like you, and also for people who are doing totally different things with video, it's just really complex.
Yeah, like, if I make a blog post and I paste in an image, it's not very hard. But if I want to include a video, I have to use YouTube, basically, which is okay, but it's certainly not ideal. Like, I have to snip in YouTube. That's kind of weird.
Yep, this is true. And it's just because video is 100 times harder to deal with than images. I think that won't be true forever. I think smart people will figure out a way to do what you're asking.
Okay, guys. Well, it's been great talking to you. I really, the time flew by, and I'm fascinated with video infrastructure. It's a deceptively difficult problem. I guess you look under a microscope at anything, and you find layers and layers of complexity. But certainly the case with video infrastructure.
Yeah.
Yep.
Absolutely. Thanks for having it. This was fun. Really appreciate it.
Thanks to Symphono for sponsoring Software Engineering Daily. Symphono is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symphono.com/sedaily. That's symphono.com/sedaily. Thanks to Symphono for being a sponsor of Software Engineering Daily for almost a year now. Your continued support allows us to deliver content to the listeners on a regular basis.
Wow!